I think as a general rule, it's a nice thing for anybody that's getting into open source that doesn't feel like their coding is up to scratch yet. It is a kind of great way to get involved in other projects is by doing logos or other kind of little artwork bits and pieces like that. And I think it brings the projects to life. I don't have any data on it, nor have I done any research whatsoever, but 80% of open source projects with a logo probably are going to do better, aren't they? And that's science.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. Do not underestimate the power of the independent open cloud for developers. Yes, I'm talking about Linode. Linode is our cloud of choice, and it's the home of changelog.com. What we love most about Linode is their independence and their commitment to open cloud. Open cloud means being unencumbered by outside investment and maximizing value for the community, not shareholders. And that's exactly what Linode represents. No vendor lock-in, open at every layer. If you want to learn more, head to linode.com/open. Again, linode.com/open.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. We have some great guests coming down the pipeline. Tom Steele with Black Hat Go, Derek Collison of the Nats Project, Denise Yu from GitHub, and the return of Francesc Campoy. Subscribe now and tell your friends. They'll thank you later. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about immediate mode GUIs. What does that mean? And specifically we're going to be taking a look at the Geo project, which you can check out on gioui.org. And we're going to find out what that's all about. Joining me today, well, it's only Johnny Borsico, isn't it? Hello, Johnny.
Hello, it's just me.
It's just
Nothing
you,
special.
mate.
Yeah.
Very special, I think. And also special, John Calhoun.
Hey, Matt.
John, I did a compliment for you in your intro.
Also special? Is that what you said?
You had to call that out.
Yeah. Well, last time I think I said you should be tolerated. So I wanted to be nice.
Guess I'm moving up.
Yeah. Well, don't worry, though. We're also joined by somebody who's I've seen speak and does some great presentations. You can check them out online. It's Elias Nawa. Hello, Elias.
Hello, Matt.
Welcome to the show.
Thank you very much.
I'm really excited about this episode because I saw your talk at GopherCon last year, 2019, and it was excellent. Could you just kick off and tell us, what do we mean by immediate mode GUIs? What does that mean?
So immediate mode is in contrast to retained mode, and retained mode is the design or the way to structure regular or most other user interface libraries. So retained mode is where you have a lot, if not all of your user interface state in the user interface library. So the example I like to use is the browser, because almost everyone knows a little bit of JavaScript programming and the browser DOM. And in the DOM, you store all that is visible on the browser page, and also, of course, many things that are not visible. But for our case, it's the visible thing that we're interested in. And the thing about retained mode is that you usually have, at a very high level, you have your program state duplicated. So if you have, say, a list of contacts or something else you want to display on a browser page, you typically have that list twice. You have some representation in your program that you got from a database or from the network or somewhere else. And then you have it, in the case of Go, you have Go structures to represent those contacts. But on the other hand, you also have that information stored in the DOM in case of the browser, because you have a DOM element for the label of the name of the contact, and you have a DOM element that represents the image, the profile image of the contact, and so on. If you have other information on that page, well, that's also represented by elements, by DOM elements. So in contrast, immediate mode gets rid of all that state from the user interface library and replaces that with something that, if you've ever done any video game programming, you would know the structure of a video game is essentially a giant for loop, not a giant for loop, but a top-level for loop that simply loops and asks whether there's any input from the user, say from the mouse or keyboard or whatever your device is, and updates your state, the game state, so to speak, and then draws it. And then on and on it goes. For immediate mode user library, it's almost the same thing, except that you don't want to do this all the time because that would be a waste of resources. So you, instead of the for loop that goes on and on, you have a for loop that waits for events at the very top level, and that's very neatly modeled with a go switch statement. No, not a switch statement, a select statement of channels. And the interesting thing about immediate mode is that one of those events that you're waiting for is an event that essentially says redraw everything. And that's what immediate mode is, that you draw your entire program state, not your entire program state, but the state that is relevant for the screen for what the user should be seeing in the window.
It draws it every time. I mean, it draws it in full.
Draws every time.
Right.
It's basically drawing everything, because what you can do, and we can get back to that later, is you can cache what you drew in the previous frames, and that is done for you automatically in systems like libraries like GU, so that even though the program behaves and uses the library as if it were drawing everything from scratch every frame, it will only what will actually be recomputed and drawn to the screen is what more or less what differs from the previous frames, or for the previous 5 or 10 frames or something like that. And the great thing about that is that you don't have this duplication of state. And that is just not just the duplication for, say, the labels. So let's take an obvious example. If you have a window and one label inside it, you will, again, in the browser DOM, you will represent that label or you will bring that to the screen by constructing a new element and putting, say, a P element, a paragraph element, or a div element, and then put the text inside that, and then add it to the DOM, right? So in immediate mode, you don't do that. You, in your update function that redraws what is relevant, it will notice somehow that the program wants to display this label, so it just draws that label, and that's it. And again, back to the retrain mode example, if you say you have this label that represents a name and the user, and an update to the profile comes from the network that says, well, the user's changed his name or something, then you have to change that name in your structure, which is unavoidable, but you also have to have an existing reference or obtain a reference to the DOM element that represent the names. And sometimes the name is displayed several times in the same user interface. You have to update all those duplicate state somehow. And again, if you want to remove a label or remove a contact or something like that, then you have to go in and take the element out. So not just duplicating the actual state, which is the username, you're also duplicating, so to speak, the metadata of that label, which is, does it exist at all? Where is it? Where is it positioned? And so on. And again, in immediate mode, you simply just you get an update, say, okay, I'll redraw or respecify my entire interface and draw whatever is relevant. And if you don't need the label, then you just don't draw it. So that's the drawing example. And I like to say that user interfaces have 3 major tasks. The first one is drawing things. So draw the button, draw the text. And that is actually very, very complicated because it has to be done, especially text is very complicated to draw. But at a high level, it's not that interesting in the sense that that's more or less a solved problem. It's not trivial to do, but it's a solved problem. What is even more interesting is the second task, which is layout. Layout is simply the job of positioning your thing. So instead of using, I'd like this label to be positioned on this X and Y coordinate, and I want it to be this wide and this high, and do that for every element and make sure that they don't collide and they react to say, if the window sizes changes or anything else. That's very, very difficult to do for anything other than trivial programs. So layout is simply a way for your user interface library to give you tools to automatically place, or not, maybe not automatically, but place things relative to other things. And a common thing is, for example, centering that label inside the window. If you want to center it, then again, from the browser example, you have to add more state. which is in the browser, you could probably set a property, a CSS property on the P or D div elements. For some other libraries, you need to construct a container element, and especially if your layout operation is more complicated than just centering. You have to construct a container widget, which is not even visible, and put the label inside of that container and tell the container, center whatever is inside you. And then again, you have another state introduced twice, because you have the knowledge that you want to center it in your program, which might just be implicit from your program. And then you have to encode that state in the browser in the form of a container or properties. And again, back to the immediate mode, as you draw the label. In Geo, there's simply something that could be condensed just to a function that says center this thing. And on Geo, it's implemented as a function that takes another function, and everything you draw or specify inside that inner function, well, it's just centered. And then that's it. There's no knowledge from the library that you have centered something, and there's not something that you should update the next frame to say, well, now it's not centered, it has to be right aligned or something like that. So the state is, again, it's implicit and it's gone as soon as you've used it, so to speak. And the last task for any user interfaces, which is, I think it's most interesting, is event handling. And that's where, at least in my opinion, where retained mode libraries or the design of retained mode leads to the most unmanageable programs and applications. Because what they do, what most libraries do, is that they force you, if you want to, say, have a button in your layout, not in your layout, in your interface, and react to that being clicked, then you need to register some things, typically a callback. In Go, it could be a function or a closure where you say, okay, to this button, set the event listener or click listener, whatever, to this function. And that, again, means that you have state hidden, not exactly hidden, but you have state duplicated in your user interface library. In the DOM, you say set, I think it's set event listener or something like that, and you call it click, and then you give it a JavaScript closure or a function. But in contrast, and that of course leads to, when do you remove this callback? What if this callback is invoked? Because you can't really, a lot of bugs are hidden in the sense that they only trigger when you click the button at the wrong time. That's a very typical example of something that can be very difficult to deal with in traditional user interfaces. What if the user clicks it on the wrong time? And that almost never happens because the user almost always behaves nicely, if you can say that. He or she clicks the button when it's time to click the button and don't click it when it's not relevant to the user interface. But sometimes they do anyway, or because of delays or something like that. And then you get a weird crash and have to debug that. So again, back to the immediate mode design, you don't have the state. You don't want state in the user interface in the library itself. So you don't have callbacks. What you do instead is, as you specify the interface, you, at some convenient time, convenient for you, the programmer, you ask the button, have you been clicked since the last frame? And that's just if check. And if you have it something like a toggle button, then you can do a for loop, say as long as you've been clicked. If you have, say, a user that very, very quickly clicks a toggle, say a checkbox twice, then you need to update the state twice. But other than that, it's more or less just an if statement, say if button clicked. And that's actually what you write in Geo. If button clicked, and then update your state. Do whatever you want. Show something, print something to the screen, initiate a network request, whatever you want to do. And that is it. And again, if you don't want to handle events because you're not ready to it, or the program does not expect the clicks to happen from this button, then you just don't check it. You don't have that, you don't execute that if statement somewhere in your program. So adding and removing, so to speak, the callback is done automatically because there are no callbacks. And you get to handle this button click where you want it. At this point in my program, I'm ready to handle the click. Then that's where you write that if statement. If you have a callback, then you don't know really. It's not that it is multi-threaded, so you don't have a data race as such, but you can have, your program is not in a well-defined state when you get a callback from the user interface library, because it detects the click and then it calls the function, and who knows where your program is, whether it's really ready to accept these input events. So that's the three, say wide and large tasks that user interface libraries handle, and where I think that immediate mode really makes a difference.
I do have, as you were sort of explaining sort of how this mechanism works, I was kind of picking up on some of your terminology. You were talking about frames, and that sort of took me back a little bit to when I was sort of exposed to folks doing work with, maybe I'm going to age myself a little bit here, but Macromedia
Casper?
Director. Casper. Technologies like Macromedia Director, Flash authoring, Flex, and that whole sort of category of tooling. And even there are some more sophisticated things out there as well have come out. But all these things sort of operate on a sort of a timeline, if you will, right? It's almost like you are expected, there's an expectation that you're going to be moving through, the quote unquote frames, right, on a timeline at a given rate, at a given basically frames per second kind of rate, right? So is there a loop, right, that within, in this case, Geo, where basically you have the opportunity at the next iteration of the loop? Are you redrawing everything, or why are you using some of that terminology? Like, how does that connect back to these kinds of sort of a timeline-based sort of animation and sort of a creative tooling?
It connects back because that's exactly what happens. You have a for loop at some top level. In a Geo program, you have a for loop at the top level of your program typically. And that for loop typically contains a select statement, which waits for events from, say, the network, but also from the window, which feeds the event channel with frame events. And frame event is simply a request from the system for any reason to redraw you. And then in essence, you go through, again, the whole user interface as it is right now, not your whole program state, as I said before, but you go through the relevant program state necessary to redraw the window as it is now. And you say framing and timing. There's not an explicit timeline as such, but the interesting thing about what you're saying is that to animate things with immediate mode and GU, that's the most simple thing you can imagine. And that is simply asking for the frame events at regular intervals, which is typically when your monitor will refresh, say, 60 times per second if the 60 hertz monitor, or even more if it's on a phone. But you ask the GU system for, I'd like to animate things. More concretely, what you do is say, my state is changing all the time. So you get these frame events at regular intervals, and you simply update your state according to the current time. And that's it. That's how you animate. So if you want something to fly from one part of the screen to the other side, you simply start with positioning it at the beginning, ask for these frame events as long as you're animating, and then slowly move that, say, a button along the path. And it could be a spline, it could be a linear path, it could be whatever you want. And the cool thing about this is that you still have to program the animation, which is not trivial, but it doesn't have to be built into the user interface library, right? So most other, as far as I know, retained mode libraries need some way for you as a programmer to specify, I'd like to animate this property, say a button going from green to red, if you want to animate it going from some state to another. And you have to tell it, okay, I'm starting with red, I'm ending with green, and it has to go through this path, this curve, follow this curve, and it has to take, let's say, a half a second or 100 milliseconds and so on, and then say go. So you describe this animation typically to the user interface library and apply it to a property or a set of properties, and then make it do the animation, which is very convenient, of course, but it's also very inflexible because you can't do anything. You can do many things, but you're not free to change your user interface libraries in any way you like it. You're only free to do it in the way that the library expects you to do and have added support for doing, right? So I think that's one of the many advantages is that something like animation is taken completely out of the picture. You can just not talk about animations if you like to, because it's not really relevant to the library.
It's interesting. So in having this in immediate mode, presumably you draw the whole thing from scratch. So you kind of start with clearing the screen, do you, typically? And if you're doing that very quickly, then drawing has to be very fast. So how does Geo draw things quickly? Is it just that it doesn't take that long to draw things? Or is there something else that Geo does that helps keep it quick?
So two things. First thing is that you don't explicitly say clear screen and then draw this and draw that. What you do is, as a program developer, you actually specify your interface as a list of operations. So you say, okay, I want an area here which is white, and on top of that I want this button-shaped blue blob, and on top of that I want some text, and so on and so on. So what you end up is a list of operations that describe at a quite low level what your screen is going to look like. And you pass that to the GU renderer, which you don't know anything about, but you just pass it along and say, okay, do whatever you want with that. And what GU can do at that point is that it doesn't do that much yet because it's pretty fast already. But what it can do is that it can recognize sort of a diffing algorithm. It can take, okay, what did you draw in the last frame? And what are you drawing now? And what are the differences between these two operation lists? And it can do that very efficiently because GU decides, I decide in the API what is the format of this operation list. So it can be constructed so that it's very easy to find the differences and then just draw that difference. That's the one reason. And the second reason, just very shortly, is that it uses the GPU to draw, and the GPU is screamingly fast, even on phones.
Hi there, this is John Calhoun, one of your GoTime panelists. When I'm not working on GoTime, I create programming courses that help developers level up their Go skills. And one of my more recent courses, Algorithms with Go, is live, and I wanted to invite you to check it out. So it's completely free, and in it we explore how algorithms and data structures work, as well as how to actually implement them in Go code. So if you've ever had an interest in learning about algorithms or data structures, or if you felt like you understand them conceptually but just couldn't nail down that coding part, this course is going to be great for you. We actually dive into coding everything, we work on practice problems, and it's a lot of fun. You can sign up completely free at algorithmswithgo.com/GoTime. Again, that's algorithmswithgo.com/GoTime. And don't forget that last /GoTime bit. It helps me keep track of how you found out about the course so that GoTime gets credit for referring you. Thanks for listening.
So, assuming I'm understanding this correctly, whenever an immediate mode program, or something like Geo is rendering, and you say it's like this for loop that continues iterating every time, I assume that means that every single time, one of the ways that you're avoiding bugs is you're essentially getting like a snapshot of all the data, because like you said, you're not duplicating it. So you don't have to worry about that, like, well, I was in the middle of changing something, but it's not quite done. So because you get like, this is the data every time, it presumably should make things more like easier to replicate. If you give it this set of data and tell it to render, you should see the same thing on screen every single time. Is that correct?
Yes. A GU drawing function or set of functions and methods and so on is basically an iterator that goes through your program state, however you've defined it, and then outputs GU operations to draw it. That's a very, very high level view of it. Okay. And so yes, it is stateless in the sense that the same input in your program should give the same results at all times.
So would it be fair to say that React was kind of trying to make immediate mode sort of available to people working in the DOM?
Yes.
Okay. I was just trying to make sure I understood that all correctly, because it seemed like a lot of the sales pitch React had was like the same things you're pitching of, you've got this state, you don't have to worry about all this, it does all that for you, and you're not like trying to alter all these things.
Yes. I haven't used React, but what I've seen from it is that they still have an explicit representation of state. And I don't know why they have it. Perhaps it's a limitation of trying to put an immediate mode library such as React on top of something that is fundamentally retained, such as the browser DOM. But as far as I can tell, they still have some kind of explicit state tracking. So you decide what the state is, but you still have to give that state to the React library somehow. And again, I haven't used it. And then the React library will, in some automatic magic way, sort of diff between the previous state and the updated state and make sure that the updates happens efficiently.
Yeah, it uses a virtual DOM to... Yeah, and it is that. And we're actually using Svelte. That you build the same kinds of things. It's a JavaScript framework. You build the same kinds of things, but all the processing happens at compile time. So there isn't a lot of runtime in the browser with Svelte. It's just they do all that work kind of at runtime. So I think that's quite interesting, but it's still conceptually, I'm not sure where it fits in with those. But it's really interesting to hear about that. I was just going to ask, so you mentioned like clicking a button. When I had an Amiga, and I used to love building UIs on this Amiga, and you actually didn't have any frameworks then. You just, you could draw rectangles and lines and pixels and circles, I think, and you could fill and not much else, So to do things like even change the state of a button on hover, It was a case of catching the mouse events and then comparing, through some, the way I used to do it was just kind of global X, Y on the screen positioning. And so I would just check, is the mouse kind of greater than the X, but not greater than the X plus the width of the button? And that told you if it was in this part of the screen, and same for the Y axis. And then you could know. So does Geo have to do things like that at that low level? Does it deal with any other kinds of abstractions, or is it literally kind of from the ground up, it's dealing with those sort of low level problems?
So Geo as a library is from the ground up. When you consider what to base your UI library on, it's very tempting to use something else. Say, for Android and iPhone, for example, they have a very, very rich set of widgets, and they have a lot of behavior already encoded in those widgets. So many frameworks take the approach of reuse and say, okay, we'll just reuse whatever is available on the platforms, and then try to make that behave the same across platforms, which of course works pretty well in the beginning, but then, at least in my experience, breaks down the devil is in the details, essentially. So Geo went the same route as Flutter. It's actually inspired by Flutter in the sense that Flutter is the Google's cross-platform Dart library for doing cross-platform user interfaces. And they took in my eyes at least, very bold step of saying, we'll never use, as far as I know, the native widgets and toolkits. We'll only require somehow to draw some access to your GPU. It can probably render in software if you wanted to, and some way to access keyboard and mouse events. So yes, in essence, Flutter as well as Geo does at the lowest level handle events like that. So the button has been programmed to say, okay, it will register an input area, say, I'm interested in pointer events in this area. And then whenever it's inside that area, then it will hover or react to it if it's been pressed and then released, and only if it's pressed and released inside that area, and so on. So all those low-level checks, so to speak, and pattern matching on the input stream is done at some level. But of course, it all boils down to when you're using a Geo button in your program, you simply say, you have a button, you draw the button and ask for it. Was it clicked? That's it.
Great.
But it's done in a way so there's nothing magical about that button or the editor or the other widgets in Geo. There's no tricks up the sleeve, so to speak. So you can actually take the button and modify it as you want. And you can do that in practical terms because the source is unlicensed. And modify it to however you want to. And it will render in the same way as the built-in, so to speak, widgets. So there's nothing magical about the built-in widgets. It's just the widgets that I've deemed that they're generally useful and then added to the standard library, so to speak, the standard Geo library.
So what's the code look like for a Go programmer then? If you're going to describe, say, a container with 3 buttons in there, maybe a dialog box with some label and then 2 buttons, how do you describe that in Go code? Or are you talking so low level that there's literally a draw or an update interface or something and you just have to implement that?
I can show a program but that would not be very useful on a podcast. So what you're asking for is, what is the structure of a typical Geo program?
Yeah, would you create a struct that describes a kind of view and have that contain sort of child nodes of the things that make up that page? Do you build it in that kind of...
No, you will do it. Actually, it depends on the program, of course. If you have something in a program that needs to be dynamic, so say you have a list of users, then you need somewhere a slice of user objects, I suppose, which is then filled in from somewhere else, and then you need that slice to represent a dynamic number of users. But say you have one button, and a label beside it, and just that's it, then it's actually, and that's one of the great things, and also perhaps a bit surprising, is what you do is you simply say, draw button, draw label, that's it. It's a little bit more complicated because you want the button and the label to be beside each other and not on top of each other and so on. So you typically have a layout object around it, but that's not an object that you construct and then save. You on the flies, you actually construct a value object in Go, which is very easy to do, like a struct constructor. Say setting the margin or the alignment, whether it's right, left, or center. You construct a value object and you call a function on that, which takes a closure that is another function, which you define. And inside that function, you can draw things. So if you have, say, a flex layout, which is a way of putting things on either a row or in a column below each other or beside each other, you can say flex, and then it takes a variable number of child functions, so to speak, and each of those functions is a widget. So if you want a button and a label, you take this flex object, call its layout method, and the first function you give it, you draw the button, and the next function you give it, you draw the label. And then the flex object will make sure that the two widgets are placed either beside each other or on top of each other, depending on the direction.
So are they given bounds then at runtime? Does the layout component say, okay, I want you to draw and here are your bounds, essentially. This is the space you have to draw in. Or does the layout component somehow apply that information before it then gets drawn? Do you see what I mean?
Yes. So in GUI, there's a layout protocol. It's implicit in the sense that you can't guarantee that the widgets follow this protocol. But what happens is that there's a global context, which I usually call the GGX. It's more like the Go standard library's context object, but it's the context for GUI programs. And that context at all times contains the current constraints, which is sort of what you were saying with the bounds. And the constraints simply say you can have in the X direction, you must be at least this number of pixels wide, but your maximum is this number of pixels, and the same thing in the Y direction in the height. So you get constraints sort of as an input in this context, and it's up to the widgets to fill out a dimensions, a concrete size, width, and height that they chose to be layout-wise. So they can draw outside these bounds if they want to, but this is what will be used for layout operations. You can sort of imagine this is a recursive process. So the flex will give each and every child element some constraints, and we'll use that to place the next one, and so on. So yes, yeah.
That's really cool. Yeah, it's nice to know that because, of course, everyone's going to probably, if you're building an app, you're going to need those kinds of layouts. To be able to say, spread these elements out evenly, or this is the one that can expand to fill the space, these are the two fixed, those kinds of things. Mm-hmm. Yeah, they are very useful. And I saw in some of the source code examples, it is really quite easy. You just sort of create these, it is like a tree really, isn't it, of elements. Yeah, it works all the way down. Really interesting. So what sort of use cases is this for? I mean, when you look at it on the GOUI.org, so GIOUI.org, when you look at it on there, it does look like an application framework for building kind of front-end apps. And by the way, on that website, there is an image of an example view, I guess, that you've rendered. And I was blown away because there's a little run button next to it, which I almost missed. And clicking that sort of ran the WebAssembly version of it, didn't it? Which is crazy. So it supports WebAssembly?
Yes, but not very well. Well, it supports WebAssembly in theory, but in practical terms, the Go implementation of WebAssembly, it's an entirely different discussion, but it is very, very bad. I would say, because one thing, WebAssembly is not that great either, because it lacks support for something such as threads, for example. You only have access to one thread, and its interface for example, for GUI, I need the access to WebGL, which is the browser way of doing hardware accelerated graphics. And you essentially have to call a reflect-like interface from Go, which then calls into JavaScript, which then invokes the browser's underlying WebGL implementation. And as you can imagine, that is very, 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 very inefficient. And on top of that, the WebAssembly bytecode, the virtual machine of WebAssembly, is a stack-based machine, which fits very poorly to the current Go compiler and so on. So the code is not very efficient. So it works on WebAssembly, and it's correct in the sense that it's the same code that runs in the browser that you're creating that runs as a native, application, but it doesn't run that fast.
Yeah, you probably wouldn't use it, would you? The reason I brought it up was just really, I'm quite impressed by how portable it is, because of course it runs on Linux, it runs on macOS, iOS and tvOS as well, and Windows and Android and things. So yeah, having that portability, I think that is another quite interesting thing, because of course Go is cross-platform. But lots of the different choices that you have when you want to build lower level things, you tend to have to sort of be specific to a particular architecture sometimes. So it's great. How does it do that? How do you keep that abstraction? Is it just that you're dealing with the common low level things like drawing and receiving events?
So I think the primary reason it is so portable is that I made the same choice as Flutter did. And I think they made the choices for the same reason. They wanted something that was optimally, maximally portable. And to do that, you simply have to as you would in any other case, you have to reduce your dependencies as much as possible. So GEO has almost the minimal dependencies you can have, which is simply somewhere to draw and somehow to receive input events. And then everything else is done in Go code. So actually, I just, it's so portable, I released a unikernel version of GEO. So it actually, I have a port that runs without an operating system directly in QEMO. That's how portable it is, because it really only needs somehow to draw the graphics, somehow to receive the input events, and that's about it.
So when I'm looking at this example, like the kitchen example on GEO's website, I think what's kind of interesting to me is that it's easy when you start running it to sort of just think, oh, this is just HTML elements or something. Like it almost, you click, you can add text, you can type, all that stuff works. But I'm assuming that this is actually just like either like a canvas or something like that in the DOM. Is that what you're doing and just writing to it?
Yes. It's a canvas with a WebGL context attached to it.
Okay.
And that's another reason why even though we got Go to run very efficiently with WebAssembly, you may not choose it anyway to use in the browser, because you kind of have the same problem as you have with Flash or with Java applets of the old. It's much, much better integrated in the browser, but it's still not so well integrated that you can sort of select this element and inspect it from the inspector, and it doesn't integrate 100% with the rest of the page if you have if you have that.
Could just use HTML and CSS, I suppose.
If you have something that you need to be very, very slick, then you should, use something that is native to the browser. But of course, if you have a project which is primarily an app or a desktop application, and you need a quick and dirty way to draw that in a browser or activate that in a browser, well, then that's a perfectly viable way to do it, because the code is literally the same. So other than dealing with a different size and so on, then it's the same code.
So like visualizations, it would be quite a cool use case for it, because it would be great if you could render some data visualization in Go and then just have that kind of, you might just render it into an image and serve it that way, I suppose. But yeah, anyway, it's a cool thing to play with. And I think one of the things GEO has is this kind of playability. As soon as you see it, you feel like, I could build something with this, and I can tell people have that sense about it.
And it's also very easy to do, for me to do examples, live examples, like you have examples on the Godocs page or the package Go dev. So just like you have with the kitchen example, essentially, I wrote an article comparing the immediate mode to the retained mode way of designing your user interface. And I used live examples. For example, I used the DOM example, of course, which is native to the browser, but I could very easily integrate small snippets of GEO code and actually run it. So I could demonstrate. And I hope and expect that would be very useful for doing the future tutorials and articles and so on. So in the same way as the Godoc examples, which are also playable in the sense that you can change them and play with the examples and run them from the browser. If you can run these examples from the browser, then I think the WebAssembly port is worth it just for that.
Yeah, I agree. Absolutely. And it is great if you go to, that website, and we'll put it in the show notes. There are definitely some things to play with.
We deserve a better internet, and the Brave team has the recipe for bringing it to us. Start with Google Chrome, keep the extensions, the dev tools, and the rendering engine that make Chrome great. Rip out the Google bits, we don't need them. Mix in ad and tracker blocking by default, quick access to the Tor network for true private browsing, and an opt-in reward system so you can get paid to view privacy-respecting ads, then turn around and use those rewards to support your favorite web creators like us. Download Brave today using the link in the show notes and give tipping a try on changelog.com.
When you look at the website, you do kind of get a sense that it's for applications. But what about games? What about kind of more fun things that you could potentially use to build? Is that viable?
Yeah, sure. An issue you have with games is that you typically want a very low-level access to your graphics card. If you have anything else than the most basic games, then you need this access. And GEO, for portability reasons, only more or less exposes the operations that are necessary to do a 2D vector-based user interface as well. So what I've done to cover this use case, because I really want to cover those niche use cases well, Because one thing that happens when you introduce something like this to the world is that all the Go programmers say, well, that seems like a good idea. But if you ask a so-called front-end developer, he will say, why should I care about Go at all? So I have to learn a different language just to use your framework. So I'm trying to reach those niche where you have enthusiastic Go programmers anyway, or you have an existing bunch of code anyway. And I think that games is a very good example. Also because I used to do computer games not in a previous life, but 15 years ago. So the problem is, of course, that you need the low-level access. And the great thing is that is also solved by GU being very portable. So what you can do is you can extract GU and only use the widgets and the layouts and all the tools that are in the GU Go code, the portable Go code. And then you can attach another renderer to it. So there is somewhere in GU that translates these operations, say circle there, rectangle there, and background there, text there, translate that to GPU commands. And you can take those commands and intercept them and merge them with whatever you have. So if you're writing a game, you typically use some kind of game engine, whether you're writing it yourself or it's some third-party thing. And you need all the drawing to go through that. By splitting up the GU from the actual operating system or native part, it's very easy to integrate with games. So yes, it's very, very much a thing that I'd like to see done with GU. But the point is just that GU in itself does not make writing games that much easier. It makes writing the user interfaces much easier, of course, I hope. But it doesn't really help you with the details of, say, writing a 3D game or a 2D game or so on. So even though it's using the GPU, it doesn't give you the tools to efficiently and portable do an interesting game with. That is not quite true. So the guy that did Egon, who did the logo for GU, has done some interesting animations with GU, which is done quite inefficiently because GU doesn't give him that much to work with, but he still manages to get something that renders quite quickly on his machine. So it is, I suppose, possible to do a game if it's vector-based and so on. So yeah. What
is your ideal application that you'd like to see built with GU? If something would just pop up and just blow you away and just excite you, is there anything in mind, whenever you were building it, that you'd really love to see built with it?
So what I wanted to do, and I started to do, and I presented a very early version of, was a chat application which is completely decentralized, because I'm interested in decentralizing all the things, so to speak. So I did something called Scatter, and it even has its own domain name, as Matt would say. I bought scatter.im. And the idea is very, very shortly that you use email as a message transport instead of have a centralized service. But something like that would be very interesting to do. An interesting user-facing popular app for phones, because users on phones are the most picky. You don't see many new desktop applications done these days. And if you do, it's an administration tool or some editing tool. It's a workhorse. It's a tool of some kind. But if you do something on the phone, then it's meant to be for the, so to speak, general public, and it needs to be polished, and needs to be have all the corner cases covered and so on. So that would excite me quite a bit. So I've actually been hired to do an Android app. So I hope that will come out at some point and blow you all away.
Are you going to use GU?
It's going to use GU, yes.
Oh, that is cool. Well, you mentioned the logo. I think projects should have logos as a general rule. Open source projects like this one, the GEO logo is very good, I think, by the way. So compliments to, who was it who did it?
It was Egon Elbra, if I pronounce his name correctly. He does a lot of these Go illustrations and logos and so on. And at some point, I think I mentioned on Twitter some months ago and say, well, it has a name, it has a website, but doesn't have a logo. If anyone has ideas, something like that. And I think half an hour passed, and he came up and said, I'll do one if you like. And we did a bit of back and forth on the Slack channel, and then he came up with the current logo. And I completely agree. I love that logo. It perfectly embodies what I think GU is. It's simple, it's vector-based.
Immediate.
And immediate, yes.
As soon as you look at it, it's there.
Yeah. Bam.
It is very good. But I think as a general rule as well, it's a nice thing for anybody that's getting into open source that doesn't feel like their coding is up to scratch yet. It is a kind of great way to get involved in other projects, is by doing logos or other kind of little artwork bits and pieces like that. And I think it brings the projects to life. I don't have any data on it, nor have I done any research whatsoever. But 80% of open source projects with a logo probably are going to do better, aren't they? And that's science.
And you've just introduced an artificial barrier for every open source developer out there. Now, way to go, Matt.
Oh, what?
I mean, he did kind of make a tool that makes it a little bit easier to make gophers, that you can generate a logo.
That's true.
Yeah. I mean, to be fair, Ashley McNamara really deserves the credit for that project. My involvement was putting PNGs over on the top of each other.
Okay. You did a little bit of work, and Ashley did all the heavy lifting. And then you got to say, I've got this really big number of combinations, and Ashley only drew like this many illustrations.
Exactly, yeah. I made the billions of possible gophers possible.
Right.
Yeah.
So Elias, I'm interested in hearing what you define as success for Geo. Obviously, we've talked about sort of use cases, what you'd like to see people create, what your own ambitions are around sort of being able to create with the Geo itself. But I'm curious, what does success look like, right, for you with this project at this point?
I would say two things. The first thing is Geo 1.0, which is where I hope that we can say, okay, the API is stable, and we want in the same sense as the Go compatibility promise. So we can release a module, let's say 1.0, and then we're not going to change the API. If we are, we're going to release it version 2 and so on. So all the promises that will make people in turn say, okay, I think this is a cool project, but I don't want to deal with the APIs changes all the time. And those kind of people can start using it for real. So that's, I would say 1.0 is a very, very important milestone. Also because to reach that, you don't just need the features to cover all the necessary features to reach at 1.0. What is even more important, you need to have enough users so that you can be certain or relatively certain that you've covered all the things that would come up when you're doing an application. I can't say that now that all the things that I've done up till now will be frozen, because I don't know whether a use case will appear that disqualifies that API that I've done. So when 1.0 is reached, I know that there will be enough programs using this and being hopefully happy about it. And so we can say, okay, practical use has shown us this API is pretty good. So, and the second thing is probably that the funding of the project, that is well funded, so that the buzz factor hopefully increases, or is it decreases? I don't remember. And also so it's viable in the sense that the people working on it actually does it because they can be supported while doing it. And that's actually been done quite well up until now, in the sense that a handful of people have signed up for my sponsorship page on GitHub, and especially Emmanuel from Tech. He did a very generous sponsorship, even though he's not really using GU for anything. So sponsorship is very important. But also what I'm going to work on is this Android app. So we'll both hopefully validate GU as a practical thing, but also kind of say, okay, it's not just open source in my free time, so to speak, because it's full time for me. Because I see this as a business, sort of a business for me. So yeah, so viable in the sense of funding and 1.0.
That's brilliant. Well, it's that time again. It's time for our unpopular opinions.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So, who wants to go first? Has anyone got an unpopular opinion?
I volunteer, Elias.
Okay, I wasn't actually sure what kind of unpopular, and I asked Matt in his email asking me for an unpopular opinion. How unpopular, I asked him, and he hasn't responded.
How unpopular do you want it?
So yeah, that's it. So I brought two of them. One is very on topic, almost obvious, and the second one is slightly, perhaps even very off topic. And they're both at least controversial and maybe even unpopular. So which one do you want?
Controversial, please.
Both are controversial.
Oh, well, in that case.
Either one. Okay, I'll start with the very obvious, which is, of course, that in my very, very arrogant view, I think that the retained design of other user interfaces has really, really slowed down and wasted many, many developer resources to deal with it. But more importantly, and this is completely guesswork and not fine science like you're doing, Matt, I think that one of the reasons that there is a difference between a front-end developer and a back-end developer, so to speak, or that there is a distinction at all, or a very common distinction, is that many developers will simply be fed up with the tools that they're available for doing user interfaces. So you sort of say, okay, this is very, very tedious. It must be because I'm not very good at it. And then they sort of say, I must be a backend engineer because I'm not capable of dealing with all this complexity and tediousness, and why doesn't this work, and why do we have to use all these libraries and so on. So at least controversial, perhaps unpopular opinion.
No, but it's a good one. Do you think if we hadn't ever had this retained thing, we'd be like on Mars by now? Like, do you feel like it's really held humanity back that much?
Perhaps the moon then, again.
The moon, yeah.
A few more times to the moon. I'll take that.
Right. Yeah. Okay, cool. That's okay. I thought that's perfectly fine. Yeah. And I'm not sure that enough people know enough about it for that to be considered unpopular. And what was your other one?
The next one. Yeah. I wanna hear that one.
I'm excited about the unrelated.
Okay. So the only related one is short and simple. It is that I think that everyone should own a little bit of Bitcoin, and especially during this crisis we're in. So that's short and simple and hopefully unpopular.
Well, it's not unpopular to me. I already own a few, so I support that unpopular opinion.
I mean, I feel like you should have told us this before we aired the episode, so we could just ride that way. No, I don't think we're that popular.
So you think this is going to cause a spike?
I don't think so. I wish, but I don't think so.
Yeah.
I remember bringing it up at a table at some lunchtime at the GopherCon, and the people around the table just looked at me, and the only question was, isn't it really bad for the climate?
Oh, really?
I think I got the impression that Bitcoin is not very well received or seen affectionately in this community. But of course, I could be wrong. So what are your unpopular opinions?
Quickly diverting. Matt?
Quickly diverting. I think that I'm hearing that is not unpopular enough. I'd like to hear genuinely unpopular opinions.
Johnny, have you given an unpopular opinion yet? Because the thing about Johnny Borsico is, I think he's too nice to have an unpopular opinion. But what do you think?
I thought that was going to be your unpopular opinion somehow. And I'm like, that's not unpopular.
Yeah, too nice. I come up with unpopular opinions, I think, once every 3 episodes. So catch me in the next one.
Okay, yeah. That's great.
Diverting again?
He doesn't run in immediate mode. So
it's more
nice.
It's retained.
Nice.
No, I think we could talk more on the the front end developer one is always weird to me because I feel like there used to be this stigma that front end developers weren't like real developers, and it's especially now it's really frustrating in the sense that when you're working in JavaScript and React and all that stuff, you're doing real development. There's no doubt about that. Now, if you're just designing pages, HTML and CSS, and like you're just making it look good, I could maybe see the argument of like, well, you're not really dealing with logic as much at this point. You're just dealing with aesthetics. And like, maybe there. But I would, like, going sort of against your opinion, I think part of the reason some developers don't do front-end stuff is because you kind of have to have that, I almost want to say design sense, or I've always felt like you have to have that design sense of being able to make something look good. Because if you can throw all the React, or not React, but all the HTML DOM elements on the page, it still doesn't look like you know what you're doing unless you can like make it look pretty. So for me, that was always one of my struggles is I mean, it's kind of like you said, the tools are kind of not amazing in the sense that I'll be there after an entire day and be like, I've got one page looking good. That's it. Where did my whole day go? You're doing something back end and you're like, oh, I just got all these things working and it's great. But it's also frustrating in the sense that back end sometimes it's hard to demonstrate what you're building. It's hard to show people that.
So you just said something that I think is perhaps I've gotten hints of that, and because earlier in my career I started at doing sort of more front end and design kind of work, so I also got a sense of that as well. You're conflating all the different roles, right? I think most of us would be considered, by front end folks to be back end, folks who work on stuff behind the scenes, right? Stuff you can't see, right? So By thinking that, okay, I can sit down as a developer and just come up with a beautiful front-end application that not only looks good, but the user experience is good and the functionality behind the scenes is good, and the remote server that this thing talks to, is good. Like the proverbial full stack, as we call them. To think that one person can do all these things well, and I'm not saying those people don't exist. I'm just saying that that's like conflating different disciplines, right? So UI is different from UX, right? Which is different from being able to program, right? Given UI, after the UX has been done, right? So these three things alone are different disciplines, right? Sometimes you have folks who are talented enough that they have all these sort of qualities and can also do the coding behind the scenes and do the back-end work, but that's a lot of things, right? And in my experience, if you're doing all these things, you are going to have a stronger area of focus, right? Very rarely do you do all these things extremely well. All the time, you are going to have stronger areas, but I think there's this sort of false belief that one person can do all of these things. I don't know, perhaps startups look for the one person who wears all the hats. That way they don't have to hire all the disciplines, but who knows? But that's the idea. That's what I'm thinking, that we shouldn't conflate all these disciplines because they are disciplines in and of themselves. They require study, they require understanding and knowledge and expertise.
I think it's especially challenging because, like you said, startups will... Like if you start with one developer on a startup, they kind of have to do everything. They might not be great at it all, but they have to do it all. And then when you go to hire, usually the way that gets split up is there's like one front-end guy. And by front-end, I mean he's doing UI, UX. He's doing probably some coding still. Like he's doing all these different things all put together, and they just sort of define it as a front-end developer. And then the larger a company it gets, I feel like you're correct, definitely, that these things get isolated and you specialize in what you're really good at. And that ends up having much, much better results, I'm sure. But it's just very hard because, like a lot of these smaller companies are it's almost like everybody's hiring using the same terms, but looking for different things. And that makes it really challenging.
You're right about there's something about the size of the team I think is important for this, because David and I, we're building something and there's just two of us working on it and we're doing the whole stack. There's pros and cons to that. One of the pros, of course, is we can think about a user experience thing and know how, all the way down to the database, how that's going to work. When the problem is small enough and you can do that, you can deliver quite a really good experience doing, paying attention to all the bits in that. As the team grows, realistically, that becomes much more difficult. Although I have seen teams of, small teams of essentially full stack developers where there's no roles. Everyone's just responsible for everything. And some people are naturally better at one area than others. And that sort of happens even within back-end development too. But yeah, there are pros and cons to it. I think the more you can do, the better, because like you say, you get that nice joined up experience, but at scale, it starts to get difficult. And then of course you need then even more people to be able to kind of glue the other bits together. So suddenly information architecture, which is another UI discipline that's separate to UX design and UI design and stuff. So yeah, I think it's a tricky one. And I think team size comes into play quite a lot. I don't know. One question I didn't ask you, though, actually, was this one, which is, how does Go talk to the GPU?
How does Go talk to the GPU?
Yeah.
It depends on the platform, actually. In WebAssembly, you simply call this syscall/JS package, so the JS package, which is kind of a reflect package for JavaScript. So there's a WebGL commands, functions implemented, exposes as JavaScript functions, and you can call them directly from a Go program that is built for WebAssembly. But for the other platforms, you typically use CGO to interface with a DLL, the dynamic library that exposes an API that gives you access to the GPU. So that is typically OpenGL on most platforms. But for Windows, you can also use OpenGL on most platforms, but the best thing is to use is Direct3D. So there's actually two backends. In GU, there's the OpenGL and there's the Direct3D. But on Windows, it's actually very interesting because the syscall package on Windows is capable of dynamically loading DLLs and then invoke functions from those DLLs. So you can avoid CGO on that platform.
Yeah, that's crazy. But of course, Geo's done all this work for us, right? We don't. If we use Geo, we get to get all that for free.
Don't have to deal with you don't have to deal with that.
Does that make, like, if I build something using Geo, does that make building it and sending it off to different platforms a little bit more challenging, or how does that work?
So for Windows, because it's not using CGO, you can build a Windows GU executable from everywhere you have Go. For Android, you can build it if you have the Android SDK installed and the NDK, because it's Android. For macOS and iOS, it's of course
iOS.
it's Apple. iOS. Yeah, iOS. So macOS and iOS.
Good Lord.
It's of course it's Apple. So you have to have an Apple machine more or less. And you have to use their tool chain to build the Chico that enables you to access the native parts that you need.
Building for the Apple TV is quite a promising little, enticing little thing, isn't it? Imagine building your own TV apps in Go. Yeah, we may have to do a hack day on that. That could be really fun. Yeah, it's a great project. Thank you so much, and thanks for coming on the show, Elias. I hope you will come back and talk to us again.
Thank you very much.
Yeah, it was great to have you. Thank you. And for everyone else, we'll see you next time.
We would love to hear your unpopular tech opinions. Tweet them at GoTimeFM. Use the unpopular opinion hashtag, and you might get a retweet. You might get read on the show. Who knows? You might get ignored. These things happen. This episode was brought to you by amazing sponsors. Thanks again to Linode, Fastly, and Rollbar for always having our back. It was produced by Jared Santo. That's me. And our music is brought to you by the one and only Breakmaster Cylinder. Thanks again to Elias for joining the show, Matt for emceeing, and John and Johnny for playing wing. Y'all are awesome. Did you know we have a master feed? Yep, you can get all of our podcasts in one easy feed. Head to changelog.com/master. Subscribe there. If you like GoTime, you will love the changelog. You will love practical AI. You will love brain science. Hey, you might even like JS Party. I hear it's pretty fun. That's all for now. We'll talk to you again next time.
When I came to the US and I kept hearing about Casper. I'm like, what is this Casper thing everybody keeps talking about? Like, it's like, Dad, this is a childhood thing, like Casper. And I finally saw Casper the Friendly Ghost, right? The sort of the original, I don't want to say black and white, but it was like an old, either a short or film or something. And I was like, oh, okay, Casper the Friendly Ghost, right? And I started seeing Casper like on mattresses and things. I started seeing Casper like everywhere. I'm like, what? I don't understand. This is confusing. But
I don't get that. Is there what is it? Why is everyone talking about Casper so much, Johnny, when you moved to the US? Is Casper just like all the thing?
I don't
You've
know.
not seen Casper? You gotta see Casper!
I know.
Everyone just loves it.
Yeah, everybody's talking about Casper. I'm like, I gotta see this Casper cat. Turns out it was a ghost.
It's like Game of Thrones of its time. He's a ghost, but he's friendly. It's such a twist.